Hello everybody, good afternoon. So all of you are aware of the theme of the talk, and I will be basically giving you a brief overview of what is my feeling about this theme, that is energy and security constraints or trade-offs I use in this slide. So when actually Himanshu invited me, to serve on the panel, I started thinking, so when he's saying security, what is that we actually mean by security? So I considered an example of a C system, I would say, consumer electronic system, and with some typical components, like it has a DSP, embedded processor, memory, and so on, and OS, of course. So if we consider this whole, system, the attacks that can be possible on this system are actually in multi-forms. Control, wanted to see. I want to do full screen mode. Okay, yeah. So multiple forms of attack are possible. So starting from the attack on the hardware itself. Okay, so most of the people, when we talk about, when people talk about security, typically we have a tendency to talk about network security and security of the information or of the data that is being processed. But it is also equally important that the system, security of system itself, so that we can trust the system and we can trust the system is doing what it is supposed to do. That is one aspect. Then another aspect, so much data we are talking about in the first panelist mentioned about IoT and so much data we can process through the IoT. So the copyright or the ownership right of the information is also important. Then in the from the hardware IP point of view, so in the global supply chain of hardware, what we are dealing with right now, we may have soft cores designed by one company, goes to another company, and so on in the global supply chain till it reaches the foundry. The IP core of the hardware passes many phases. So in the process, somebody can really attack the IP of it, and that means misuse the IP and use it for other hardware purposes. So anyway, so the summary of this slide is the attacks that can happen in the C system are in multiple forms, starting from the hardware itself, the network aspects, the operating system, then the information or data being processed. So if you take an example here, for example, let's take a smart car. Okay, so we see in the smart cars, we have hundreds of millions of lines of code, okay, in the and we have hundreds of electronic control units or microcontroller units in the car. So all these can be actually hacked. They are all prone to security. And there are, if you see in the internet, a lot of videos are there how different cars are being hacked, and which is a really safety concern. That means you have a smart car and you are a driverless car, and somebody has hijacked it and driving it the way he wants, not the way you want. So if we want to have some kind of mechanism, let's say encryption and so on at the top of it, okay, we'll have a problem here. The reason being the connected vehicles, like this safety intensive kind of driving that we're talking about, okay, they need to have faster communication because the car needs to make some certain decision based on the data it is processing from the lidar and camera and so on in the millisecond time. And then if it's operating on the battery, the battery will have its own lifetime. So any security feature that we need to add at the top of this, okay, will have some impact on the energy efficiency and the latency and so on. So this is an example of smart car, which is a C example. Another example, this is like UAVs in the last 5-10 years are really everywhere, people are talking about. And I think in the CS, there were some shows by Intel where there are hundreds of UAVs were flown. So all these UAVs have really issues in terms of security. So they can be hacked. And then the adversary takes control of over it and can crash it or can basically fly it in the direction that they want and so on. So this kind of C systems, again, will have security problems in the form of different hardware components as well as softwares. For example, control system will have its own set of securities, then logic systems and so on. Then so if we add any kind of payload in the form of encryption and so on, okay, we'll have basically impact on the battery life, the latency, weight, and aerodynamics. So all these basically have issues, so trade-offs needs to be done because as a result of that. We had the keynote one on smart healthcare. So we were discussing that security is a major thing in the smart healthcare as well. And the examples that the keynote speaker was giving, I want to bring those to your attention. That is, for example, pacemaker. Somebody is having a pacemaker, which is very life critical. And if somebody hacks it, and then instead of the battery life, which is supposed to be, let's say, of order of 10 years, okay, and somebody drains the battery, then that person it's a life-threatening situation. So security is important in the smart aspects. And then he was also giving a very good example that I have in the January issue of C magazine. We have a issue on the smart healthcare. Okay, there also we discuss one example how insulin pump can be hacked. And in the process, the amount of doses that insulin pump needs to provide can be changed. And then that's a problem, health hazard for the user that is using. And here is a specific component. NFCs are everywhere that we are using in the C for the ID card point of view, or even payment point or contactless payment and so on. So this is a example of a C component that needs a lot of security, and a lot of attacks are possible, starting from eavesdropping to spoofing and so on. So here again, if we add additional features, we'll have a power impact. This is another component. Everything needs memory. Okay, and memory. Information or data can be taken away in many forms. Okay, so starting from snooping to so on, and cold boot attack, all these things. So we need to have mechanism for that as well. This is what I consider is important thing for the C industries. That is the counterfeit hardware. I call that as a IP intellectual property attacks. So here, this is a slide that talks about different analog hardware in different sector of consumer electronics. They are used, and as a result, we have a lot of basically profit loss for the semiconductor market. Okay, so this is not only just the monetary point of view, but it can be also safety hazard as well. Suppose, for example, we have a counterfeit or fake issue in a car, okay, and or you have a bad battery, okay, fake battery in a mobile device. Okay, all these are safety hazards. So this, I think, is a C industry point of view important aspect. So if we say attacks, many forms of attacks are possible, as we discussed in the first slide. Okay, so we can say based on, so there can be software-based or there can be hardware-based. Software-based attacks where communication channel happens, and these are remote. These are very frequent. We see all the time in the news and so on. Okay, and hardware-based attacks, on the other hand, can be local. Okay, they're difficult. Okay, then many forms are possible. So which is more important and so on depends on the context. Similarly, in terms of security solutions that we can provide for these attacks, we can have software-based solution as well as hardware-based solution. And what is a good solution for C industry will depend on the application and battery life and so on. So software-based, yesterday I was asking for to the second keynote speaker, he was from McAfee, that what is his comments on software-based versus hardware-based. Okay, so basically he agrees with whatever I have here. So software, no doubt, is more flexible, and you can have in multiple platform buying same software, but software needs to run on a general-purpose processor, which will have its more power consumption. On the other hand, hardware security can be custom-built, and it can have minimal power consumption and probably more suitable for the IoT kind of application. So maintaining security and other trade-offs in the IoT and CPS, probably hardware versus software trade-offs can be done. So what I define as, I call that as a hardware-assisted security, because most of the security solutions, people have a tendency to use more software-based security. And the software-based security, what I call that, it is using a deterministic machine, okay, and a deterministic machine getting random numbers is a big deal, okay. So because all these encryption and so on depend on random number, but all the, whether it's a custom IC or even all the general purpose processor, they are deterministic machines. So we are really not getting enough random, but still we have reasonable solutions, but these solutions can be broken in the period of time. So probably hardware assisted solution that has a good hardware solutions can have better security. So what I call as a hardware assisted security, that security that provided by the hardware for the information being processed, and it can be the copyright as well as security, then the hardware itself, and then the overall system. So then we can have additional hardware component used for security, or we can modify the hardware design and so on. So in the process, different components, starting from RF, infrared, memory, then digital IP, and the information in itself, all these need different types of solutions. So so I was doing some little bit thinking, so what should be our design axis? Okay, so I thought probably security, then recurring operational cost, non-recurring design cost, performance and latency, energy consumption. So these 5 different axes we have to have design trade-offs. That is what I thought is a good solution. So here is an example. For example, as a typical C system, where the idea is we can have, let's say, a low power kind of solution, but then different component-wise we optimize depending on the application. For example, lightweight cryptography or better compression and so on, and then we do the trade-offs. Then this is memory point of view. Okay, we can have, let's say, hash and so on for the memory, but this will again consume additional energy, and latency impact will be there. Then this is the application of biometrics for the NFC, where we can have security, but again this is affecting battery life as well. And this is, I'm talking about changing the design flow. For example, we can, when we are transmitting a soft core from vendor A to a user, to a buyer, then soft core in the process doesn't get in Trojan and so on, basically doesn't get inserted by some adversary. So to take into account, we can have IP core design flow such a way that that Trojan can be detected. Then another we talk about is obfuscation. This is structural obfuscation, where we are making sure that reverse engineering is made difficult. So these are articles are coming actually in the near future in this year. Okay, so thank you.
Panasonic.